Hello, this is the fourth of my moles videos, and this one is to show how moles can help with balancing equations. It links into the AQA specification points 4.322 and 4.323. This one really is just a quick one about balancing equations, and the reason we have to balance equations is because atoms cannot be created or destroyed. They also cannot be changed from one type of atom into another. This is called the conservation of matter. And a really big thing, you must always use an arrow in an equation. It means time passing. The thing you can never do is put an equals, because you've got a before and an after, from the reactants to the products, and there is an arrow to show that you had this lot, chemistry happened, and now you've got this lot. Now, you need to make sure that you have revised your Unit 2, Topic 2 on bonding, to be able to know why it would be O2 in Li2O. But simply put, once you've calculated these things, you can't change the small numbers. So this tells us that every lithium in lithium oxide, well, there's 2 of the lithiums for every 1 oxygen. Again, chemists are lazy. If there's no number, we can put in a 1. What I do when I'm balancing equations is I can put a little dash below to show what I've got before and what I've got after, and these numbers just come from me looking up here. Again, there's no number, so it means a 1. I can't change this ever. I can't put another small number in, and that's why I'm always writing that in to make sure I don't make the mistake. So you can go either way. I'm going to look and see, hey look, I've not got enough oxygen on the right hand side. I can't change that to a 2 because every oxygen has 2 lithiums stuck to it, so I have to change the big number. That now means there's 2 times 2, there's 4 lithiums, and 2 times 1, 2 oxygens on the right hand side in the products. There were 2 oxygens before, and so that works. However, I've not got the lithiums right. So now I go back, I've got 4 on the right, I need there to have been 4 here. I can't change the small number, so I have to put a big one in, and that's it, correct. Now you don't have to do these bits below. This is just my way of notating and making sure I get it right. The key thing, we'd be putting a 4 there and a 2 there. So what's this got to do with moles? Well, simply put, the big number tells you how many moles, and if there isn't one, then it means 1. So 4 moles of lithium react with 1 mole of O2, and that will make you 2 moles of Li2O. And again, the 1s are just there when to show that that's what it is. It doesn't get written down, you don't need to have it. So let's go down and show how we can use moles in even more detail to make sure that we are correct. And I just do these equations in the order BMR. The B is for the balanced equation. If you want to give a shot for this yourselves just now, go for it. 2 chlorines here. I'm not going to write it out because this one I've picked for you is a bit simpler. We have to put a big 2 in there. There's now 2 lithiums, so we have to put a big 2. Now, the M is to work out the molar mass of anything. Remember, you've got to look to the periodic table. Lithium has a mass of 7, so that we're just going to put as a 7. This is Cl2. 1 chlorine is 35.5, so this is 2 times 35.5, that's 71, and LiCl is 7 plus 35.5 gives us 42.5. The point when the moles really come in and help you is the R, and that's actually the reacting mass, where you take the number you've got here and you multiply it by whatever the number of moles was. So there's 2 lithiums, so this is 2 times 7, which is 14. There's nothing written here, which means there's 1 mole of it, so 1 times 71 is just 71. And then there's 2 moles of lithium chloride, so 2 times 42.5 gives us 85. Hopefully you're now spotting where this has really come together, because if you look on the left, 14 plus 71, it equals 85. So you can really double check that you've got things right.